Alright guys, this is problem 11 of the 2018 AMC 10 Test B. Alright, and this was when I first approached this problem, I thought it was pretty difficult, but after some thought, I realized how actually pretty easy this problem was, okay? So let's read it, alright? So it says, line segment AB is the diameter. Alright, hold on, let me get my brush out. So line segment AB is the diameter of a circle with AB equals 24. Alright, so let's draw that out. Alright, whenever you see a geometry problem, you always want to draw stuff out. Oh my gosh. Alright, let's draw a perfect circle here. Ready? Alright, you know what? That is close enough. Point C, not... Alright, here, let's draw the diameter. AB. This is A. This is B. Is equal to 24. Point C not equal to A or B lies on the circle. As point C moves around the circle, the centroid, center of mass, of triangle ABC traces out a closed curve missing 2 points. To the nearest positive integer, what is the area of the region bounded by this curve? Alright, so they're telling us that point C is going to move around the circle, right? So let's draw our first example, point C. Let's draw in the color red. Draw C right here, okay? And so point C not equal to AB lies in the circle. And they're telling us that when you have ACB, and that'll be a triangle, right? ABC is a circle. So we're going to draw a circle out of here. Or, I'm sorry, a triangle. So we have triangle ABC, and they're telling us, and the centroid is just where all the medians of this triangle ABC connects. Alright, so let me give you a median is from the vertex to the middle of the opposite end. Alright, so let me draw that in the color green. Alright, so let's draw dotted lines right here. Go into the middle. That's one median. Let's go into middle, and that's another median. And that is another median right there, right? And so right here, this is the centroid. That is where all the points connect, right? So let me draw that in green right there, okay? So that's our first median. And C is gonna go. It's gonna go all the way around the circle, okay? Except for B, because it can't go on point B because that's where point B belongs. And it can't go on point A either because that's where point A belongs, right? So it's gonna be missing these 2 points, all right? And so if we really, let's draw another point, instance of point C, all right? We're gonna draw this in yellow. So let's say point C can also be here, right? So we're gonna draw that out. Excuse my non-perfect lines. Draw that in yellow, and we're gonna draw it in blue, all right? The median's in blue. So our first median. Wow, that was not a very pretty median. That's our first median. Here's our second median. Here's our third median. And there's where our next median is, right? So we realize this median, all right, it's gonna go around all the way like this, all right? We're just connecting the points of the median. And it's gonna take up this small little space right here, okay? Because we realize the median is gonna go all the way around, except for it's missing this point right here, and it's missing this point right here. And it's asking us, to the nearest positive integer, what is the area of the region bounded by this curve, right? These two curves, the region bounded by this curve is just the inside of the circle, right? Or this curve, right? Because it's not a complete circle. So we know that they're going to connect like this. And how do we find this, okay? Well, we know that C all the way, if we take C, and we take this first median right here of each C, it's going to be, you realize that it's going to be a radius of triangle, or I'm not, sorry, not triangle. It's going to be a radius of this whole circle right here, right? Because technically you're going from an endpoint to the middle, right? So we know that, let's call this middle point, let's call it D, okay? We can call it middle. So we know that DC on every single triangle is going to be the radius, and the radius is equal to 12, right? Because 24 divided by 2 is 12. So we're going to say r is equal to 12. And so our goal here is to find this radius right here, right? Because we want to find the area of this whole circle, of this bounded circle, okay? And so how we do that, all right? So we know what DC is. So, and also, if you realize another property of, if you knew the property of medians, all right? If you take a median and you see the point where all the medians intersect, right? The shorter end will be half as long as this longer end, right? That's just a property of medians. You have to know. So where all the medians intersect, the shorter end is going to be half as long as this longer end, right? And so let's call this shorter end x, and we're going to call this longer end 2x. All right? And so we know that x plus 2x is going to be equal to 12, right? Because CD is equal to 12. So x plus 2x is 3x. 3x is equal to 12. And x is equal to 4 because you divide both sides by 3. So x is equal to 4. And if x is equal to 4, that means the radius of this little circle D right here is going to be equal to 4, right? Because that's the end point and that's the middle right there, right? So it's going to be 4, all right? And so if the radius of the small circle is going to be equal to 4, then if we remember our circle area formula, pi r squared is equal to the area, alright, and we have r, or x, whatever you want to call it, is equal to 4. 4 squared is 16, and so the area of this this circle right here, circle D, is 16 pi, and they want to give us an about, alright, an about estimate. So we know that pi is equal to 3.14159 all the way to like these infinity numbers, right? So we know that pi is about 3, right? Because 1.14 is going to round down to 3. So we're just going to take this about. So 16 times 3 is equal to 48. And 48 is closest to 50 in all of these answers right here, right? And so in other words, the area of the region bounded by this curve, to the nearest positive integer, the area of the region bounded by this curve is 50, all right? And because 48 is closest to 50 in all of these answers right here, all right? And there we go. That's how we solve this problem right here, all right? And so in these geometry problems, you're gonna have to remember so many theorems, all right? But that's why I hate doing geometry problems the most, but because you have to remember all these theorems. But when you see something like median, when you see something like bisector, alright? When you see something like circle, just go back to all the formulas, go back to all the theorems, alright? Just remember them. What are properties of medians, right? What are properties of circles? Alright, once you remember those, the problem will be very easy. Alright, thank you for watching.